To simplify radicals, what we want to do is pull out all perfect squares. So what we want to do is find perfect squares, and I use a factor tree to do this. So if I take 8 and I factor tree it down to 2 and 40 goes to 2 and 20, 20 goes to 2 and 10 goes to 2 and 5, I have a factor tree of 2 times 2 times 2 times 2 times 5. Now once you have it factored out, that's these, you're looking for pairs, and that's what the square root of 80 equals. So to do this problem, I'm looking for pairs of numbers. Every pair, one comes out. I call it the buddy system. So this pair of 2's, one of the 2's comes out of the radical. This pair of 2's, one of the 2's comes out of the radical. And what's left over is the radical 5. And if you simplify this one as 2 times 2, which is 4, radical 5, we have our simplified answer. Now multiplying square roots is simply multiplying what's inside the radical times what's inside the radical. So 2 times 14 is 28, so I get radical 28. But now I have to simplify this, so I'm going to do the same method. 2 and 14, 2 and 7. And so I have 2 times 2 times 7, which is what radical 28 is. This pair means the 2 comes out. So I end up with 2 outside the radical and 7 inside the radical as my answer simplified. Simplifying with variables means we're just looking for even number of variables. So let's just do the 90. I'm going to do the square root of 90 first. And I know 9 is a perfect square, and I have 10. And then 10 and 5. So the 9 is a perfect square, which is really 3 and 3. So the 3's come out, and I have 10 inside. So I just did the numbers. Now the letters are really simple. X cubed is really x times x times x, and y4 is y, and z is, there's 5 of them. And when you have these, you're looking for pairs. So if I look at this pair, 1 comes out of my radical, so it's going to become 3, and we have an x, 1 pair of y's and another pair, so 2 of them come out. And we have 2 pairs of z's that also come out. And inside the radical, well, we already have the 10 from over here. And we also now have an x and we have a z. So we have an x and a z. So anytime you have a pair or an even number, one of them comes out. In numbers, we do factor trace, so we're also looking for pairs of numbers. Rationalize the denominator simply means we can't have a radical in a denominator. So if we look at this problem, we have radical 35, and I'm going to separate it as radical 15. And so I've just separated my fraction, but I'm going to get rid of this radical. Well, to get rid of that, I'm going to multiply by that radical. So multiplying by it. This is really 1, so I'm not changing the value, but I'm multiplying by this radical to create a pair, which means it comes out of the radical now. And if I go through the process of multiplying and then factor treeing, find pairs, let's just do on the side here. 35 is 5 and 7, and 15 is 5 and 3. And so this pair of 5's would come out of the radical, and what's left over would be radical 21, or 7 times 3. So pairs come out, but no pairs stay in the radical. And then this can be reduced. 5 over 15 reduces to 1 over 3, and you still have radical 21. So here's our answer. So if you look at my problem, B is the same thing as this answer. The last type of rationalizing is what's called conjugating, and all that means is that we have to get rid of this radical that's in the denominator. So if I write the problem, I have to figure out what gets rid of that. Well, what gets rid of that is taking exactly what you see there, but changing the sign. So I'm going to multiply by the same on top and bottom because that is really a 1, so I'm not changing the value. So I can do this multiplication. Now we'll use our FOIL method on the bottom. So 5 times 5 is 25. 5 times negative 2 is 5 radical 2. Radical 2 times 5 is a plus 5 radical 2. And radical 2 times radical 2, well, there's a pair, so they really come out as 2. So, and it's a negative, so it's a negative 2. There's my bottom. And if I do the distributive property, because I'm timesing, 3 times 5 is 15. And 3 times a negative radical 2 is a negative 3 radical 2. And if you look right here, these two are opposite, so they cancel out. Let's get rid of the radical. 25 minus 2 is 23. So I end up with my answer is 15 minus radical 15 minus 3 radical 2 all over 23. And so I've rationalized the denominator. That means there's no denominator, by using what's called a conjugate, which is simply the opposite sign when you have a sign. If you remember from the last problem, there was no sign, so all we had to do was multiply by whatever the radical was.